For the first time ever, scientists have directly witnessed a tectonic plate in the process of tearing itself apart, and it's happening right off the coast of the Pacific Northwest. Using sound waves fired into the seafloor near Vancouver Island, researchers found that the Juan de Fuca Plate, the slab of ocean floor sliding beneath North America, isn't sinking in. One solid piece the way scientists long assumed. It's breaking off in fragments, one chunk at a time, like a train slowly derailing car by car. Here's the part almost nobody's talking about. This doesn't make the region less dangerous, this exact same subduction zone is still fully capable of producing one of the largest earthquakes in North American history. No guessing, no dramatizing, just the facts, the science, and the real stakes. Let's get into it. The region in question is called the Cascadia Subduction Zone, a roughly 1,000-kilometer fault system running along the Pacific coast, from Northern California up through Oregon, Washington, and into British Columbia. It's one of the most closely watched seismic regions on the planet because it's a megathrust fault, the kind of fault structure capable of producing earthquakes above magnitude 8.0, along with tsunamis that can travel across the entire Pacific Ocean. To study what's actually happening deep beneath the seafloor there, researchers used a technique called seismic reflection imaging, essentially an ultrasound of the Earth's interior. During a 2021 research expedition called the Cascadia Seismic Imaging Experiment, scientists aboard the research vessel Marcus G. Langseth sent sound waves down into the seafloor and captured the returning echoes using a 15-kilometer-long line of underwater listening sensors trailing behind the ship. Combined with detailed earthquake records, that data produced high-resolution images of faults and fractures far beneath the ocean floor, images clear enough to finally answer a question scientists had been circling for years. At the northern end of the Cascadia Subduction Zone, off the coast of Vancouver Island, two smaller oceanic plates, the Juan de Fuca Plate and the Explorer Plate, are slowly sliding underneath the much larger North American plate. For a long time, the working assumption was that this process, called subduction, happened as a smooth, continuous, gradual descent, one plate essentially bending and diving beneath another in a single, connected motion. What the new imaging revealed instead was genuinely surprising. The plate isn't descending as one intact slab. It's tearing apart into distinct fragments as it sinks, deep fractures where the oceanic plate is literally snapping. Lead researcher Brandon Schuck described it as the first time scientists have ever captured a clear picture of a subduction zone caught in the act of dying, meaning caught mid-process, actively breaking down, rather than reconstructed after the fact from indirect evidence. It's worth understanding why this tearing happens instead of one smooth, continuous slide. As an oceanic plate is pulled down into the mantle, it doesn't experience uniform stress across its entire width. Different sections of the plate can be pulled at slightly different rates or encounter different resistance, depending on the exact geometry of the mantle material below and the specific angle at which each section is descending. Over time, those uneven stresses build up until the plate simply can't hold together as one continuous sheet anymore, and it fractures, breaking off a chunk that then continues sinking somewhat independently from the rest. Researchers compared the process to cutting the cars off the back of a runaway train. By tearing off in smaller pieces, the larger plate loses momentum and pulling force gradually. It's not a single catastrophic failure, it's a slow, ongoing disintegration happening piece by piece, likely over an extended geological timescale. This isn't the first time scientists have found evidence of a subduction zone breaking apart this way, but it is the first time they've caught the process actually happening live, rather than examining the aftermath. Off the coast of Baja California, researchers have long studied remnants of the ancient Farallon Plate, fragments known as fossil microplates, that are widely believed to be leftover pieces of a subduction zone that finished dying out millions of years ago. For years, scientists suspected these fragments were connected to the slow collapse of an old subduction system, but the exact mechanism by which that breakup actually happened remained unclear. The new observations from Cascadia strongly suggest these ancient Baja California fragments likely broke apart in essentially the same, gradual, piece-by-piece way researchers are now watching unfold off Vancouver Island, giving scientists a working, present-day model for a process previously only inferred from ancient geological remains. Drop a comment and tell me, did you know a tectonic plate could break apart into pieces like this? If you want more fact-checked breakdowns of the science shaping our planet, subscribe to the channel. It's free, and hitting like genuinely helps this reach more people. Let's push for 5,000 likes on this one. Naturally, the question everyone in the Pacific Northwest actually cares about is what this means for earthquake risk in a region that includes major cities like Seattle, Portland, and Vancouver. Researchers are being careful and specific here. This discovery does not significantly change the overall near-term risk assessment for the Cascadia region. The subduction zone remains fully capable of producing very large earthquakes and tsunamis, exactly as it always has been understood to be. What the discovery does change is the level of detail available for modeling future earthquake behavior. Scientists are now specifically investigating a genuinely important open question: whether a major future rupture along this fault could travel across one of these newly discovered tiers, or whether the fractures might instead change how seismic energy spreads through the region, potentially limiting or redirecting the reach of a future quake. Neither answer is confirmed yet, but incorporating these newly identified breaks into hazard models is expected to meaningfully improve how researchers simulate and understand seismic risk in one of the most consequential earthquake zones in North America. The research team, involving roughly 20 scientists across institutions including LSU, the University of Washington, Oregon State University, the U.S. Geological Survey, and Woods Hole Oceanographic Institution, continues analyzing the full CASI-21 dataset as part of an ongoing community-wide effort to understand Pacific Northwest earthquake hazards. Further modeling work is expected to focus specifically on how these newly mapped tiers might influence the behavior of a future major Cascadia earthquake. Research that could meaningfully shape building codes, tsunami evacuation planning, and emergency preparedness across the region in the years ahead. There's something almost strange about learning that the ground beneath a major, densely populated coastline isn't failing all at once, but is instead quietly, continuously tearing itself apart in slow motion, piece by piece, over a time scale far longer than any human life. It doesn't make Cascadia more dangerous today than it was yesterday, but it does mean scientists now have a genuinely unprecedented, real-time view into exactly how one of Earth's most powerful and consequential geological systems eventually comes apart, one fracture at a time. Subscribe so you don't miss the next deep dive into the science shaping our planet.